Hi, I'm going to try and go over how to run an hour of code. So to start off, we're going to watch this video.
This December, we are recruiting students from all over the world to participate in 1 hour of code. We're aiming for 100 million students, and we need your help to make it happen.
The Hour of Code is an hour-long introduction to computer science for all students. No previous experience is required, and the activities are designed to be self-guided, empowering students to learn at their own pace.
This matters because the number of computing jobs in the United States alone is rising 3 times faster than the number of computer science graduates. At this rate, by 2020, there will be more than 1 million computing jobs unfilled. And these are good jobs. We expect to have more than 20 different 1-hour tutorials to choose from, each introducing computer science in its own way for all students from K through 12.
For example, we are expecting one tutorial to teach how to create an interactive card using the programming environment Scratch.
Another from Khan Academy will teach the basics of JavaScript, a popular programming language.
Our own tutorial will introduce some computer science principles through a series of puzzles that are fun to solve. You can offer the Hour of Code on a range of devices, including tablets, PCs, Macs, and smartphones. There will even be unplugged tutorials that can be completed without any computers at all. Now let's talk about how to run the Hour of Code itself.
You can do the Hour of Code anytime between December 8th and December 14th. That's Computer Science Education Week. Our goal is to reach 100 million students worldwide by the end of that week.
The first thing you will need to figure out is where you will do your Hour of Code. One option is to use a computer lab with internet-connected PCs or Macs. Another option is to do the Hour of Code in your classroom using tablets or smartphones, as long as they can access the internet. Students can also take turns doing the Hour of Code in your classroom using a shared, internet-connected computer. In fact, we encourage students to do the Hour of Code together in pairs or small groups. Research shows that students retain more when they program together. The unplugged options can be done anywhere, even outdoors. These activities are especially fun for groups and really illustrate the point that computational thinking does not require a computer. Next, you'll need to select which tutorial to use. The week before the Hour of Code, you will be able to visit our website to preview the available tutorials. If you're not sure which tutorial to pick, we'll recommend one for you. We encourage you to try doing the selected tutorial yourself before your class does it, so you can answer any questions that might come up. Finally, it will be time for your students to do the Hour of Code themselves. Have them visit our website and choose the tutorial that you selected. If you're doing an unplugged tutorial, pass out the materials and explain the rules. Your students will enjoy doing the Hour of Code. The tutorials are designed to be fun. Students who finish early can try a different, perhaps more advanced tutorial or help other students. And that's it. As you've seen, offering the Hour of Code to your students is easy. It requires minimal prior preparation and no prior experience. In just 1 hour, you'll have given your students an engaging and meaningful exposure to the world of computer science and help demystify what can be an intimidating subject to some.
Go to hourofcode.com and help us make history.
Okay, so what we're going to do is go through what you would go through if you were going to start this with your kids. So the first thing we're going to do is go to code.org, and we're going to watch another video, but this one is going to inspire your kids to be interested in the subject.
I was 13 when I first got access to a computer.
My parents bought me a Macintosh in 1984 when I was 8 years old.
I was in 6th grade.
I learned to code in college.
Freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters, and I wrote this little program. then basically just add a little bit to it. And then when I needed to learn something new, I looked it up, either in a book or on the internet, and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than, sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
Should probably know your multiplication tables.
You don't have to be a genius to code. Do you have to be a genius to read?
Even if you want to become a race car driver or play baseball, or build a house, all of these things have been turned upside down by software.
What it is, computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
When I was in school, I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool, and, I'm learning a lot, and some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry,
snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office and places where people can play or relax, or go to think or play music or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that, you can start something in your college dorm room and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
Okay, so that video always cracks me up because obviously I was not a great programmer, because I don't know if you've ever seen my office. It doesn't look like any of those places. But still, it's about learning critical thinking and being exposed to it in the library and just working together and collaborating. So once you show the kids the video, we're going to get started learning how to code. And so we're going to go to the tutorials. And I think we're going to focus on this particular one because I think it's a good introduction to the building blocks of computer science. So once we start, there's going to be another video.
I was in 8th grade when I learned to program.
I first learned how to make a green circle and a red square appear on the screen.
You just learn these lessons, and there aren't that many of them, and you just eventually can get to the point where you can do almost anything that you want.
Computer science is just learning how a computer works and how it thinks so that you can teach it to do new things.
These days, what you can do in computer science is pretty much amazing.
I think it's the closest thing we have to a superpower.
In the next hour, we're going to play a game that will teach you the basic concepts of programming. Usually programming is all in text, but we'll use Blockly, which uses visual blocks that you drag and drop to write programs. Under the hood, you're still creating code. To start off, we're going to build code for a program that will help this angry bird move through a maze to get to the evil pigs that stole its eggs. Blockly is split into 3 main parts. On the left is the bird's maze, where your program will run. The instructions for each level are written below the maze. This middle area is the toolbox, and each of these blocks is a command that the bird can understand. The white space on the right is called the workspace, and this is where we'll build our program. If I drag the move block to our workspace and press run, what happens? The bird moves forward 1 box on the grid. And what if I want the bird to do something after the move forward on 1 box? I can add another block to our program. I'm going to choose the turn right block, and I'll drag it underneath my move block until the yellow arrow appears. And then I'll drop it and the 2 blocks will snap together. When I press run again, the bird will perform the commands that are stacked from top to bottom on our workspace. If you ever want to delete a block, just remove it from the stack and drag it to the trash can. After you've hit run, you can always hit the reset button to get the bird back to the start. Now let's get those pigs.
Okay, so this is what it's going to look like. The very first puzzle. I should also mention, if you sign in with a teacher account, you can actually get these solutions down here. And I also went through and printed them all out, which I can send to you guys. But so we've got the bird, and what it's saying here is start. And once I start, I'm going to move forward once. And then I think I need to move forward 1 more time. And then let's try that. Okay. And the second one. Even though we're going in a different direction, we're still moving forward. So we're going to do move forward. And move forward 1, 2, 3 times. Okay. Now it starts to get a little bit more complicated. So for the third one, I think we're going to go forward, forward. And then once we are here, let's try turning right. And then once we turn, we still have to go forward again. If you make a mistake, it will tell you that you used the right blocks, but you just have to change them or work on it a different way. So this goes on, and what it does is, let's see, so if I go to, I think it's number 9, 4, 5, 6, 7, 8, 9. 10.
Every athlete knows that you get good by practicing, by repeating the same moves until you get really good, or until you reach your goal. When I was in high school, I wouldn't leave practice until I made 10 free throws in a row. Similarly, when you get to a computer program and repeat a command, you can give it an exact number of times to repeat. Or you can define a goal and tell it to repeat the command until it reaches some goal. In the next example, the repeat block is changed. Instead of specifying how many times you want it to repeat, you can use the repeat until block to tell the Angry Bird to do the same thing until it gets the pig or until it crashes into a wall. And again, we can put multiple blocks inside the loop and repeat a series of actions.
Okay, so we're going to move the repeat block. And I think we're just going to move forward until we get to the pig. Okay, and then when you get to the end, you can actually get a certificate. And I think you get the idea. So you do the puzzles, and as you go through the puzzles, at certain points you're going to learn new structures like if, then, else loops, and until, and repeat. And they're the building blocks of computer science. And as you go through, there'll be 2 or 3 videos that are similar with the celebrities teaching you how to use those building blocks. But they really are just fun puzzles and just a little bit challenging. And the whole idea is that the kids learn how to critically think and debug and try it out. So thanks for watching.